Good evening, everyone. Hey, yes, good evening. So, myself, Dinesh Karthik, and in this session, we are going to look into like how to start your career in data science. This is what this session is about, and like so, let's get started. First, sure. So yeah, I'm the one who is going to talk about like how you going to start your career into data science. So, who am I? So I have to tell who am I to start this your career in data science. I'm basically a data engineer who has almost a decade of experience working in different companies, different organizations, starting from small startups to bigger organizations in different countries. So that's what basically I have. That's my career background. I mean, I can go deep dive into it later if needed. So yeah, let's start it. So, who am I targeting in this particular session? The targeted audience are basically like under our postgraduate students and IT freshers who are looking for new entry into IT, or who are juniors having like a year or two of experience and trying to figure out like which is their calling, like which technology is going to work for them or what they are passionate about. And also like any data enthusiast, whoever wants to work with data just to understand what is in the field of data so that they can make some decisions later. So those are the target audience. So the level of explanations or the information that are put in this particular presentation is for those audiences. Yes. So how this particular session is uh, kind of scheduled is like we will have like four parts. The first part is like looking into like what, so generally discuss like what is data science and like what are the usage, where it is used in your day-to-day life, and all those things will be like we will be discussing in the first part. Then the next second is why, like okay, yeah, you are telling me to start, like it's a good idea to start a career in data science. Why is it a good idea? We'll be looking into this, like what are the trends and why this can be like why you should like start a career in data science especially. Yeah. And the next is like what is like a roadmap, like how we can from a student or like someone who is like not from the data background, like how you can start your career into like different ones. And also when we are talking about the why we need to career in data science, we will also be looking into like the different or like the commonly available opportunities. Generally data science, I mean, we can discuss into it. Generally data science does not only means data scientist. There are a lot of other roles which are actually kind of closely knitted inside the data landscape, which go hand in hand, and we will discuss about it and what are the roles and what are their responsibilities and what are the commonly skill sets and technologies that are required and are used. Then the how, again, like so it's like a common road plan or like a journey in which you can follow and like reach your goal. That's like a simple one, we can also explain on this. And finally we'll reserve some time for us to ask some Q&A, like anyone of you can put your question in the chat, and during the Q&A I can look into them and answer them. So that's what we are going to focus on this today and how this is the agenda. So yeah, the first one is like what is data science? Simply like that's my word, I will put like it's the art of collecting data and making sense out of it. It's not simply you can say, hey, there is a data and like this is what. It's never the case. The like you get a lot of data and like the data will never, it's like, I mean, ideally you'll think like, okay, I get data, I can find something. Maybe that's like when we are looking at some tutorial and we are studying, that's the case. But when we go into the real life implementations or like in work scenarios or professional scenarios, you have data, but it's not straightforward to make some decision out of it and make a business decision out of it. So that's why it's a big process and there is a huge industry around it. And always the data will also be not like as easy as it is. So yeah, so what is data science? So generally, like, yeah, I would like I put right. Data science is an interdisciplinary field. It goes from end to end, starting from collecting data, properly storing the data, making it retrievable, and then looking into the data, finding some patterns, coming up with analyzing it, coming up with some kind of like predictions or like proper insights. Everything revolves around data science. I mean, generally, when someone talks like data science, people are like, okay, yeah, I'm a data scientist. No, it's like everything is kind of like considered as a data science is an interdisciplinary field. So that's why you have to look into like what are the various different analogies or like different roles and responsibilities that are available. You have to find some which will be suitable for you and which you would like to work on, and then go for it. So that's basically a high level of like how I would say data sciences. So like, yeah, so generally I said that's a simple explanation, right? Yeah. Okay, I collect data, I analyze data, then I use the data and make some information out of it, insight out of it. So generally, like, okay, so you are saying that it is there. So where do I come across it in my day-to-day life? That's a major question. So first, like, I put like a basic applications, like where you are actually using an end product of data science, which you don't even might not even know, or you already know. The very first thing is like internet search. When you go to Google, Yahoo, Bing, or any search engine, data science plays a huge part there. Like how what result is shown for your search query. Then, like whatever the search term you put, everyone won't get the same answer that you are getting or the same search results. The reason is like it is custom tailored for you based on the data that is available about you, and also the different ranking mechanisms and everything that goes behind will give you like a very curated list of results that the machine believes is going to help you, and most of the case it works with the better machine learning algorithms and everything. And secondly, I would say is like recommendation engines, which is also like day to day it comes with. Example, like you're watching here in YouTube live, right? In the right side, you can see a lot of recommendations and suggestions, which is like very custom tailored for you. And most of the time, it's something that is going to interest you, and you will always watch it. Similarly, you take anything like Netflix. Obviously, you get very curated list of what you are going to like. Instagram, TikTok, like how they become famous in the sense like you kind of getting reels or like I don't know, in TikTok, like the I don't know what the terms they call there. Everywhere you get the same videos that is going to keep you hooked. Like this is something that you are going to like. This is up to your liking. So how does the system know? Like it's not only two persons who is going to view the application. So like I know if there is going to only 2 or 3% going to view this, I can say, hey, this is the video for you. This is the video for you. But we have like millions or billions of users accessing it at the same time, and the system has to give them the same, should not actually, it should not give them the same image or like the same video. It has to be coming up with some very custom tailor for each and every user to their liking. So that's a huge implication, starting from collecting data, properly storing data with big data technologies, and then writing ML prediction algorithms, deep learning neural networks or whatever, and then coming up with some basic or like your recommendation and showing it to you, hey, this is something that you are going to like. Yes. Then finally, and the other thing is like day to day you use it like image or voice recognitions, right? Like example, if you take Facebook or Instagram, any of it, you upload a picture, it will automatically suggest who is this person, and do you want to tag this person in this post that you uploaded, this image that you uploaded. How does it know? So again, that is also there. And like voice recognition, like most of us might have used like what Google Home, like Siri, Alexa, everything. So we just tell something, it's like it understands, converts the voice whatever it records into like binary, like it's vectors and everything. Then it kinds of makes sense out of it, come up with like a proper response to it, or take an action based on what you provide. It has to decide whether it has to give you a reply and ask for a further questions, or it has to go for the next level. It's like, okay, this is that it has a definitive action, this has to be taken, so should I go for it? So all these things will be part of it. So that's also used day to day. And the other is like fraud detection. Mostly like as especially in India, we have like online payment, it become like the go-to. It's like that becomes a norm. It's not like most of us carry cash. It's like we go everywhere, we pay with the card or like UPI, scan a QR code, pay it. Yeah, we are done. That's how it's going. And also there are a lot of scams going around. So how do we prevent that? One of that is like fraud detections. So the to be how do I put it, like the financial institutions or like one of the pioneers in data science field, because they have to be very methodical and have to find a proper way, because it's like huge amount of money is involved. So they are the ones who initially come up with fraud detection and everything. Now it's kind of integrated in everywhere. So they know a pattern of like what are the purchases, where are the purchases you do, and if it's something entirely out of the ordinary, they will just immediately block it. And like most, I'm not sure if any of you have got it, if you are doing some purchase which you have never done, it is entirely out of ordinary for you, most of the bank won't open the payment. You will get a call immediately from one of the bank representatives to confirm, hey, is it you? I mean, not for small amount, but for very huge amounts, you will get all these kinds of things happening. So these are something that you do, like you are interacting with data science. It's become a part of our day-to-day life, and we are not actually aware of it, or most of the people are not aware of it, like what goes behind the scene. And the next is like, this is, I would say, like a power user, or in the sense like advanced users who are like a little bit more tech savvy, how they are kind of like use day to technologies the day to day example. So that I just took it very focused for like software engineers or like tech people here in this case. Obviously everyone might have like heard about chat gpt. There's kind of the real fuss, right? I mean, obviously it should be, and it's a conversation. To be honest, at the end of the slide I would have put like, I used chat gpt to create this presentation, in the sense like whatever the things I put, I asked chat gpt to proofread it. It looking for grammatical errors, spelling mistakes, and is there any of a like, is my using NLP, like I already had fed it with my own data, like how do I usually write my post and LinkedIn or my blogs. So it already know the how my tone and style I write. If there is anything out of the ordinary, or if I have to stick with my old tone and style, it'll actually suggest me and say, hey, this is how you write it, use this. Or if I have like saying that, hey, this is like the entire thing that I want to write about, but I want to put it more professional. I'm not able to find the accurate word for this, like then it will give me the suggestion for it, what I should use. So most content creation is now kind of like, get most content creators and who wants to write a lot of things are basically using chat gpt. I mean, it's going to evolve, it's going to become better and better and better in the future. So who knows, it may even be doing like your homeworks at some day, but hopefully not, then no one is going to learn properly. Yeah. Then the other thing is called GitHub Copilots. I'm not sure how many of you are aware of GitHub. So GitHub Copilot is a new offering similar to ChatGPT. ChatGPT is a conversational AI, whereas Copilot is going to be like, you have this plugin integrated into your IDE where you write your code in VS Code, Sublime, or like PyCharm, or you can actually have like code editor, the workspace and code editor in GitHub. You integrate this plugin, you kind of write it. So it's basically like how two of you sit together and write a program. That's pair programming. Similarly, the copilot will like whatever you write a simple context and say, hey, this is a function that I'm going to write it. It kind of goes through it. It was already trained with data from all the open source code that are available in GitHub, and it's going to like suggest like a standardized or like a formatted more better code, like simple skeletons or anything, so that you don't have to write the skeleton entirely from there, or like commonly reoccurring functions, you don't have to write them again. It will automatically like kind of like give a suggestion and autofill it. You decide if you want to use it or remove it later. So these are like the day-to-day activities of like for normal people as well as tech people. That's how it is kind of going, like your data science activities. Yes. So yeah, so we just have a initial presentation of like what is data science, how it is used, where do we interact with it in our day-to-day life. So yeah, then the next is like, you can ask, okay, that's fine. So why do I need to have a career in data science? That's the major questions. Everyone is like, okay, everyone asks like, okay, what is the benefit, or is it really a good field for me to work on? So simply put, a tagline, like I said, like when you run a big business, you cannot simply say, hey, I have a feeling if I launch this product or if I add this feature, this is going to make us more money. It's not going to work anywhere. Nowadays, every company wants to see some data behind it and make sure like based on this data, they can make a proper product development, or any decision they are going to make, they need to look into their proper figures, some proper numbers. So obviously, data is going to be used, and indirectly, yeah, so everyone who is going to work around data are needed. So that's kind of a gist of like, why do you need to start a career in data science? If I go further, so just to give you a high level of why, as you can see, as of 2023, like beginning of 2023, we have, so by end of 2022, we have 94 zettabytes of data globally available across the world in our digital universe. So you can ask, like, as you can see, right? I just put a simple math, or simply it's like one zettabyte is equal to 1 billion terabyte. So you can see the scale of data that we are talking about that is currently available across the world. And out of this 94 zettabyte, more than half of it are like generated in the last 2 years, like COVID and post-COVID. So COVID kind of triggered this, everyone talks about it, right? It kind of triggered the digitalization, like it kind of kickstarted or pushed the digitalization into like 5 years ahead. So now everyone is kind of using like work, kind of most of the companies become remote or like even hybrid, or like everything, people started using a lot and lot of internet and people are using technology, and obviously it ends up producing more and more and more data. So that's why you can see this 94 zettabytes can grow like exponentially in the coming years. So if you have that much data, we need people to work on this data. Like again, I said the flow, collect those data, there are this much data available, collect those data, properly organize them, store them, make it available for retrieval for others who are going to work on the other section of it. Then people who has to retrieve this data, make some simple analysis or like come up with hypotheses for like prediction, machine learning, build models, deploy them, make it available. That's how it is. And also following that up, so these are the other simple things that I kind of came up, like I have put like where I actually got those numbers. It's not just I purely made it out of, I'm not just putting those number out of thin air. As a data person, I also did my research to come up with these numbers, and they are actually published numbers in a particular kind of articles or like proper sources. I have put them at the end of this presentation as well. So here, as you can see, by 2022, the annual revenue of like big data, so like all the data industry, is 56 above 56 million just in a year, just for big data. And like it kind of grows around it's, and also this is mostly focused on US, a little bit of global. This number is, I don't have the exact number, that's why I put like above 56 million. That's the minimum number I'm talking about. So then the next one is like also there are some research and it is being done. And after all the data trends, big data and AI trend going on, 92.2% of the big businesses are already claiming that they already investing or already have invested in big data and AI. That's what they are currently doing. And the next, like, okay, this is like business wise, money wise, we look. But a general, normally if you take like, okay, is this number going to keep on increasing? So generally, if you see per second, an average human or average person who has access to a phone, laptop, or whatever is producing a minimum of, or an average of 1.7 megabyte of data per second, including you and me. Even in this, like we are producing more and more data. Like I'm streaming data across platforms, and it's being stored somewhere and by retrieved by you. And like someone like in also behind the scene, there is a huge analytic stuff going on. How many people are watching? What are the comments going on? People, how do people reply to this comment? Do they like it or not? Or is there any abusive comments? Or is there anything that doesn't adhere to YouTube's community standards? Then automatically there is something, even before those comment gets posted, they will kind of get kind of deleted. Or if someone puts an abusive comment or something which is not meant for it, like a spam or anything, then someone will kind of report this. Obviously, like good citizens or like people who are going to netizens will kind of report it. Hey, this is some scam. Like people kind of report scam or report spam, whatever in this comment. And obviously, there is again automated pipelines that are going to look into it, filter it, categorize it, remove it, or make decision. Okay, this is not something that cannot. There is not enough positivity or confident that this is an abuse or anything like a spam, so I need a human intervention. The machine decides it and takes it to a next level, which is like some human look into it, remove it, and all this. So even like in this where I'm speaking and you listening, here a lot of things goes behind the scene. Yes. So then we talked, right, why all this is happening. Now I'm going to say, like, as we said, like data science is like interdisciplinary fields. There are a lot of things going around, and here I'm going to I'm only taking like some of the very major or like bigger umbrellas or like bigger verticals, however you call it. I'm only talking about those kind of career tracks that's kind of like hugely available. There are a lot of niches and everything going around. And also here, whatever I'm saying, right, take it with a grain of salt, in the sense these roles and responsibilities are like how do you say, they are very fluid, in the sense depending on organization to organization. Some of them may be like interconnected. There can be a place where like a data analyst and the data scientist does the same data work as a data analyst, or like that can be a place where there is no machine learning engineer. It's like a data scientist who like have qualified enough, so they are working on proper software engineering, or like a data engineer working a data analyst, what is them doing. Or it also be like I said, where I put like data comma BA analyst. In smaller companies, they kind of like work together, on the sense that the same role, the same person does both of it. When it goes to very bigger companies, they have like a very definitive section, like, okay, BA analyst versus data analyst. So all of things are going to be kind of like very specific to companies. They can change a little bit here and there. So why I'm doing what I did here is like kind of put like the very global or like the very commonly used stuff. That's what I'm kind of putting it here. So the first is like data or the BE analyst. Usually their work is like they analyze the data which are kind of already available, and they make sure like they come up with some, they find some patterns or insights, come up with them, and it is being used for making business decision or understand how the business is working on. The next is kind of the data scientists. The data scientists are more of like, similarly they are consumer of data, but what they do is like they are more mathematical or statistical focused. They kind of come up with hypotheses to understand the business, try to find some predictive ways, or using statistical analysis or statistical method that they, based on their knowledge, they kind of come up with some hypothesis, try to prove the hypothesis with a POC and all those stuff. Then when the business decides, okay, this is actually valid and it is being like bringing result and everything, then the ML engineers or the machine learning engineer comes in. So what they do is like they are like properly like hardcore software engineers who are purely focused on like predictive analysis and those kind predictive analysis or predictive models, those kind of stuff. So the hypothesis, the algorithm, whatever that is being generated by the data scientists, like they write some code and they come up with something which is like a POC kind of a pace, like a prototype. So these machine learning engineers, they take it and then they build it as a scale, like we are talking about here, right? How do you flag a command if it's abusive? Okay, they are simple. A data scientist can take some data set, write it into your local machine, or some with a very small kind of data set. They kind of run a predictive model, and yeah, they can say, hey, this is how it works. So it's fine. It really works good. Then the data, the same data model or the predictive model is being converted into a proper machine learning model. Then it is being deployed as a software application, because like it has to scale for billions of people per second. Like even now, if you take YouTube, you don't know like how many millions of billions of comments are kind of like proofread, or like they are checked for abusive comments or all these things. So they will be done by machine learning engineers. So data engineers, so these are the guys who, obviously me, so we are the folks, we kind of sit, make sure that the data is we kind of look into, make sure the data is available, taking like, how do you put it, uh, I kind of like retrieve the data, like I said, like you said, right? You post a command, it goes to the application. But for this data to be available for the consumers or the other sector of the spectrum, like data analysts, data scientists, machine learning engineers, the data engineers kind of make sure they build, design, and build like proper infrastructures and systems which read this data, or collect the unstructured data available everywhere, make it like in a proper structure and store it in efficient way, and make sure they can be retrieved in even efficient ways, so that the data analysts or BA analysts, data scientists, ML engineers, they all can use it. So in technically all this, yeah, they, even though they are like different career tracks within data science umbrella, they go hand in hand. One cannot exist with others. Without the data engineer collecting any data and storing them, the other three folks, they cannot do anything because they need data. It's not their expertise to kind of like work with the big data, collect them, and do this. And a data analyst obviously cannot, like, just like the data engineer cannot just put the data and expect some the business to make decision out of it. That's where like the data analyst or data scientist comes in, analyzes data, come up with all those stuff and do it. And also the data scientist also simply cannot say like, okay, I wrote this hypothesis and it is working, I have this working basic model, yeah, just the application has to use it. It's not going to happen. The ML engineer has to come in, convert it, and deploy it for scale. Similarly, the machine learning engineer can, I mean, there are also good machine learning engineers, they kind of do the hypothesis, but mostly it's kind of data scientist who does the hypothesis, come up with all this with the business understanding, and the machine learning engineer display in scale. And like I said, it is fluid. There can be places where these two roles are interconnected, data scientist and machine learning engineer. There won't be like a strict line between them, but they may be doing the same or yes or no kind of stuff. Yes. So now let's deep dive. Like I said, like these are the top level. Let's go like one into another. In this case, like see like, okay, let's take case of a data and BA analyst. So generally they are responsible for collecting and, I mean, processing, dating, perform statistical analysis. Like I said, you have the data, they kind of do proper analysis on the data, process them, maybe check for some stuff, and build some dashboards for the like, very simple, right? You are running a business, you need to know how many sales you made yesterday. Are you performing good? How, like, do you have enough stock? Do you don't have enough stock? All those kinds of things for the management or the business to run. The data analyst and the B analyst kind of build all the dashboards or scripts or queries, whatever they need to do will be done. And these can be used by the management to make like proper data driven decision making. Like I said, it's cannot, like management cannot say, hey, I think this season, like this product is going to work. They are not going, they cannot sell something like this. They need to have proper definition of like what is going well, what is not going well, how is their business performing as a whole. All these things they need. So generally this is like a role, skill set, and a language required. Like I said, the role is like they collect, perform data analysis, and make regular reports available for management so that they can. It can either be like simple automated reports that sent via email, or like proper graphs or dashboards built on any of these visualization tools, so that management or like anyone can go in the company can go log in and see. That's what majorly a data and BA analyst does. For this, the skill set they required is database querying. Obviously, they need SQL to query the data from wherever it is stored, and they need to know like any of these visualization tools, like how they have to visualize those data. And in the sense like you have to be very sure, in the sense like, I example, let's say I have a data set, and there can be like n number of KPI or like key performance indicators or like points which I can come out of it. I can build like a dashboard with like 100 or 200 of such things showing so and so numbers or whatever. I can do that, but like does it really going to help the business to kind of use all this 200, 300, 500 numbers? Or like for each level, like what is it required for like a upper management, what is required for someone who is working on the field, what is required for a software engineer who is working on this product, or what is required for a salesperson who is working on this product? So they have to come up with all these different sets and identify which is going to help which department, and is it really like the proper number, and what are they lacking, and how can they fix those. So those kind of things they have to identify and build. So obviously they should understand the domain this company is working on, their business model, everything. So they have to be a little bit more business knowledge to do all this. So the commonly I have put like if you can see, I have put multiple tools, in the sense they are not everything is used. So these are very commonly used depending on like company to company, project to project. You either they use one or another. So that's how I put like the very commonly used one, so that you can decide which one is going to make sense for you. Similarly, SQL is kind of the basics of data, in the sense like any role you take, you need to know SQL. Without SQL, you cannot do anything with data. Yes. So first thing, like I will go to the journey, but now itself I can say with confidence, you should learn SQL to start your career. It doesn't matter any role. If you want to have a career in data, start learning SQL now itself. Yes. Then like, yeah, obviously, like we said, to visualize different stuff, we have Tableau, Power BI, etc. There are different visualization tools. You can start focusing on one of the tool, become master of it, and based on, and also like the knowledge is kind of easily transposed from one tool to another, because like the knowledge is again the business knowledge, which one you need to show. Those are the knowledge you build, and the tool knowledge, it can be easily transposed from one tool to another. So focus on one tool, learn it now, then later you can transport like based on what the company is needed, you can change to another tool or like learn like different tools. Yeah, that's how it is. And like depending on company to company, some places you need to use like Python or R to do some reporting stuff, not like just visualization. You have some number, you have to come up with some certain numbers, build some PDF or whatever, or like take some analysis. So Python, certain places they use Python, certain places they use R, or certain places they just go with pure SQL. Or obviously not OR, is OR, not this R programming language, or they use like the Excel or spreadsheet. Obviously that's also how it started. People initially they gather all the numbers or whatever they have, put it into Excel sheet, they just write formulas there, select cells, and that's how it started. Now like we are doing it in an advanced way of like doing it in the database, coming with big data technologies and all this. But still it is also needed. Certain places you don't be needing all this. A simple Excel sheet will be enough for data or B analyst to come up with all this. So that's why that is also commonly used, or people obviously know when they are in this particular kind of career. Yeah. The next is data scientist. And specifically, I'm not going in any order. I just put them in certain order. There is no order saying that one is above the other or one is below the other based on the order. It's like I'm just there is no order in which I'm talking about these roles. Yeah. So like I said, data analyst work, they are like very much similar to data analysts. They are also very much business oriented. They need to understand the business, and then they mostly do like the data analysts do something called descriptive or exploratory data analysis, in the sense they kind of like explore the existing data or describe the data and come up with this KPIs, or like what is already present, what is happening. That's what they majorly look into. data scientists, like they said, they do predictive analysis. They build predictive models for analyzing this data, finding some patterns, and see if this going to pattern is look into. So it's like looking into the future, like predicting, okay, is this going to happen, or this is what this person is going to like, in the sense like a recommendation. So based on your past, in the sense whatever you the videos you watched in YouTube, it is predicting the future, like, hey, this is something you might like or you may like. So similarly, data scientists are looking into the future, like how to predict something, is it going to happen, or what is the confidence or like the level it is going to happen. Those things this data scientists majorly work. So what are the excuse me yeah yes so like I said, the role is again the same. They kind of discover patterns and trends, propose some algorithms, strategies for the business, and they kind of try to improve the business and come up with the solutions. The skill set, like they said, it's very much mathematically oriented. To be a data scientist, you should be knowing advanced maths and statistics, because you are going to crunch numbers with the statistics and come up with some predictive models. Yes, so that is majorly required. And like predictive modeling, and there is a concept called A/B testing. So data, that's one of the thing of product development. They use a lot of these predictive and statistical model. They run A/B testing, in the sense like, let's say a little bit of like what A/B testing is like. A big company is not going to say, hey, in an overnight they cannot decide and say like, okay, I'm going to change this button from this color to this color, or from this position to this position, or change a feature just like that. What they do is like they take a very subset of users and they try two or three, usually A B two, but most of the times like different as well. They kind of roll out the feature for different users in different subset of users, and they see like what is the success rate, or the user efficiently using it, or they are not using it, are they like not liking it. They kind of come up with all of this, like that's called A/B testing, so that it allows them to decide like, okay, whatever the hypothesis they made and the predictive that they are doing, is it working in real life. That's how they use A/B testing to finalize all this. And obviously our data analysts as well as data scientists are storytellers, in the sense like, okay, you have all this data, unless or until you cannot say or tell a story out of this is what is happening with either visualization or like simple presentations, it's not going to help. So that's also a skill set that is needed. And big data technologies, in the sense like they don't need to kind of like know end to end, in the sense, let's say mostly they are going to query some data from like a big data lake or something, so they should know like how do they should query, because like querying a data lake or like a kind of distributed system is going to be different from querying a simple relational databases like MySQL or like Postgres or MS SQL Server. So they should know the difference a little bit here, so it will help them. Yeah, as I said, the tools and technology they use are SQL databases or NoSQL databases, and like different programming languages, Python, R, Scala, Java, based on like the companies what is required. But mostly Python and R are like kind of the go-to for data scientists. Somewhere they use Java and Scala, or basically some data engineer or like a software engineer who kind of transition, who already have this knowledge, they kind of still use it. But mostly data scientists, the top two go-to languages are Python and R, most of the cases. And like I said, Hadoop, Spark, and Hive, they just, it's not like they need to develop the data lake or write the end-to-end kind of set up all those infrastructures or all this in those big data. It's more like they simply know how to retrieve data, like query those data from there efficiently, and so that they can run their analysis and predictive thinking and statistical models. That's what they need. And similarly, TensorFlow, PyTorch are these kind of like frameworks that are meant for predictive modeling. So they kind of run this and kind of use it. Yeah. Next is machine learning engineers. Like I said, they are responsible for developing the algorithms and software that enables them to deploy the machine learning kind of stuff. Like these, most of this model or hypothesis that are built or proposed by data scientists, and they will be like converting it into a proper software application, a machine learning application, and deploy it. The role is like, yeah, they have to design and develop machine learning or deep learning. I mean, I didn't put like differentiation. Generally, like anything that's go with AI comes under machine learning, deep learning, neural networks, everything comes under this. So I'm not saying that as a separate for the deep learning engineer or like a neural network advanced learning engineers, nothing like that. Just put them, all of them come under this category. That's what I meant by machine learning engineers. And they kind of like perform the statistical analysis that are proposed, and they try to fine tune it, because whatever the data scientists they propose or they build are done for like a minimalistic use case, in the sense like they have like very specific data, and they do it like not in a real time kind of a production environment. They do it like in their staging or like a local machine with a very curated data set. They try it and all this. The same cannot, you cannot directly take it and put it into the production environment and expect it to work. So these machine learning engineer also fine tune it, like saying how efficient it can be made. So they will look into it. And obviously for this, the skill set they need is to know about like data systems. How do you build like data application interfaces, a little bit of data warehousing, like what is the efficient way the data is stored so they can retrieve it. And obviously they should know software engineering because they are like building proper software applications. End of the day, everything is software application you're building. So those are the skill set it's needed. And language used are basically like Python, Scala, Java, and R. As is more of like an productionized applications. It can be R is not widely used, but it's mostly Python, Scala, or Java, or depending on the language. These are the commonly used languages. And similarly, they need to work with Hadoop, Spark, and Hive. And like here, the cloud data technologies are not needed for data analysts or scientists, because in the sense they have access to a database or something, they retrieve the data, run some analysis. But whereas here, a machine learning engineer should know about cloud technologies like AWS, Amazon Web Services, or Google Cloud Platform, or MS Azure, all this, so that they have to deploy applications. They should know what are the available services there, or like available infrastructure there, so that they can efficiently deploy their application, scale them in like for millions or billions of requests per second. So they have to know these technologies. And similarly, like TensorFlow, PyTorch, Spark machine learning, Keras are the frameworks that are basically used by machine learning engineers to build predictive models or machine learning models in scale and deploy it for a productionized use case. And next, let's go to the next search. So obviously the last one, all right, in the sense in the order, it's the last one, data engineers. So data engineers, like I said, are the first part of this entire data problem or a data project. That's how you can put it. It's like they are responsible for like designing and building and also maintaining like the infrastructure, proper data pipelines and everything, to make sure the data is kind of collected, no data is missed, and the data is of proper quality. There is no like data that is like wrong or anything that is being stored in the final data warehouse or data lake or data lake house. They have different terminologies and different setups, and there are different architectures. So lambda architecture or kappa architecture, they have different architecture for data engineering pipelines and everything. So they have to process this, store it in a proper structured way so that it can be analyzed by others. So that's what data engineers do as a whole. So like their role, they have to develop, test, maintain the pipelines, data warehouse, and look into all the data architecture. So data is not lost. So you should never have a data, the data should not be lost. That's kind of a big problem, right? And also like you have to have like there are like different concepts like real-time data and batch data. Like how fast the data has to be reflected in the end system for the consumers. Is it going to be like, if the user end user clicks something now, is it like data analysts or analysts have to have it in the next couple of seconds or microseconds, or is it okay for them to have the data after an hour or a day? So those kind of things, so they are called like the real time or non real time pipelines. And also like I said, data quality is a big emphasis here. So is the data up to the actual quality or is it not? They have to look into it. Then the next one is like the skill set which is required for this is like obviously database. They have to, everyone has to know the database or this data technologies. But here as a data engineer, they have to know even one level, like even deeper level. In the sense, let's say there is like kind of a data warehouse, like solution, distributed data warehouse solution, let's say example Amazon Redshift or Google BigQuery. The end user, they just need to know how they can query it efficiently. But for these users, they should know how to store them efficiently. So they should be deep diving into those technologies, understand how an index works there, how data can be partitioned, separated, sorted, and stored properly so that they can easily retrieve without costing much bill or taking too much time to retrieve those data. So all of these things data engineer has to look into. And they have to do the data modeling. Data modeling is in the sense like you're storing the data, right? So what is the effective structure or the most performance structure the data can be stored? And obviously the ETL is like you can either be ETL or ELT, extract transform load or extract load transform based on their use case. They have to do that. And obviously, like I said, they're also building software solutions focused for data problems. So they should be knowing software engineering and data warehousing. Similarly, like how do you warehouse data in a huge level, proper data governance, in the sense who should have access to certain type of data, how do you separate one from another, how do you store it accordingly, they have to look into. And big data technologies here, in the sense they also work with Spark and all the different ones, and distributed computing, in the sense like for huge amount of, like we had talked, right, we, as we said, we have like 94 zettabyte of data available, and let's say a huge organization has like 1 zettabyte. Let's assume 1 zettabyte of data. It's not like they can store it in a single place. It has to be distributed across many machines so that it's stored properly, no data is lost, and you retrieve the data faster and efficiently. So for these things, they should also be working with distributed computing, distributed processing, MPP, multiple, massive parallel processing. There are different concepts, and they will be working on. They have to know all this. And also, like I said, it's not all of this, a single data engineer should know all of this, but most of the data engineers know all of this based on their workloads and their responsibility and how their organization is working and the amount of data their organization is dealing with. And for this, the languages, obviously, it's like Python, Scala, Java, R, Hadoop, Spark, Hive are those big data storage technologies or processing technologies used. Obviously, they should also know, cloud computing, or like cloud technologies, like how are they going to deploy these applications, what are the different data warehousing, data lake, or data storage services provided by these technologies, and how they can efficiently use them. And obviously, like I said, like RDBMS, like normal something like MySQL, Postgres, SQL Server, versus like kind of this cloud data warehousing distributed solution like Snowflake, AWS, Redshift in AWS, BigQuery in Google. So like I said, again, not everyone should know everything, but they should have knowledge of some of it, and then they can transpose the knowledge when they work with another tool. So that's how this should be seen by the data engineers. So these are the basic skill set that comes with data engineers, their roles, and that's what they all do. And like I said, like I only majorly covered the kind of the core or like the bigger umbrella, but there are also other ones that revolves around the same inside the data industry. Like I said, there are some persons called data architect, in the sense they work on the very high level. They have to look from the top level of the organization, see like for each and every department, each and every team, how they can set up this data strategy. They work more like a blueprint of it, and these engineers have to build it. And database administrator, we are talking like different databases. All this data has to exist into the company. So depending on like the technologies they use, certain places they don't need a database administrators, certain places they need data administrators, or like the term of database administrator can be different as well, because like I said, they maintain they are the administrators of databases. They make sure like who gets access, who don't get access, or I mean that also different from different to company, who kind of has this power, or like who does this or who does that. The next one is DevOps or data ops, is like development operations or database operations. In the sense like all this, we are talking about deploying applications and everything, right? So if the company is huge and we are having like huge number of applications running, in the sense like the developers or the engineers who are building those applications, they might not have the time to kind of monitor. I mean, they usually do, it's kind of integrated environment, but like their major focus will not be like looking into if an infrastructure is running efficiently, if something's going down, going up, or something happens, something crash. So that's where this DevOps engineers or data ops engineers, they come in, and they kind of look into like majorly focus on if their major focus will be like, is the infrastructure efficiently used, or is the infrastructure running, is it breaking, how I make sure it's not breaking, and how I make sure I have like an uptime of 99.9999 percentage of all the time, so that all my services are running. To give an example how I put, right, this happened quite a lot of time in the past years, like two times or three, two, like a very like handful of times, twice or thrice, WhatsApp stopped working, if you have experienced it. And I'm sure 90% of us or 99% of us didn't be, my the first thing might not even came to our mind, say thinking that okay, WhatsApp has some issue. No, we would have thought like our internet has an issue. Everyone would have went to flight mode, switch it on, switch it off, and then see like, okay, is it working, or like switched off your Wi-Fi router and then turned it on again, and then see, hey, is it working. Then later only you might have realized, okay, my other things are not working, then okay, that means WhatsApp has some issue. So they have like that level of stability and availability, so you even think your internet is not working, because there is no way in chance that WhatsApp is not going to work, because it always works. That is being majorly done by this DevOps data data ops. I mean, data ops, like specifically DevOps engineer who focus on data. That's what they call data ops. But basically, these are the people like DevOps or SRE. They call site reliability engineering. Or I mean, they are like, to be honest, like I cannot put all of them together, but they work on the same line of duty. That's how I kind of can say it. I'm not like kind of exactly saying they are the same, but they are kind of related and they do kind of similar work. That's how I can put it. Then like engineering managers, or basically like you cannot have like all the developers doing everything and making decisions and communicating with the business. A lot of things are happening. So it's more like engineering managers, or like mostly managers with like technical background. They kind of think on a product perspective, think like how their product in the sense is working, how they can improve it, what are the features that is going to help the organization. All these things, these kind of engineers, they kind of do, and they do some little bit of people management. Look all the whether the engineer there and the team has everything they need to work efficiently and contribute to the organization. So that's what these kind of roles do. So now, let's look into like how to start your career in data science. To honestly, like most of the points that is going to come the next, it's like it's already been discussed. So when I say it's like how to start your career in data science, it's not like I'm going to say like, hey, you do X and you will have a job as Y. That's never the case. Not only in data science, any field, it's not going to happen. I can give you a roadmap or plan, like because like I said, there are a lot of technologies and a lot of roles and everything. So you cannot blindly start, okay, I will learn like everything at the time. You cannot like achieve, or like it will take you so much time if you start learning everything at the time simultaneously or parallelly. You cannot reach a certain level for you to at least enter into the industry, because there are certain minimalistic stuff, or like the basic stuff and advanced stuff. So I will give you a plan of like going from the basics to the advanced. I'd kind of put it in a common path, in the sense you follow them, and it kind of like covers almost all the roles that we talked about, and then so that you can decide which one you want. Like I said, you cannot say like this is what. To be honest, like I wouldn't ask you to say that, okay, if you someone asked me, hey, which is the best role out of all the four, all the role I discussed, I would say there is nothing like this. It depends from individual to individual. So what I'm giving you is a proper plan, where you kind of like try to learn all of this, study them, like try to execute them, understand them, then come back to the previous set what I said, right? What are the technologies or roles and responsibility for each of it, each of the role that I have described before. You kind of then try to map, okay, this is something I really like, this is something that is not my cup of tea. So then you map it so that you can find like which is going to fit for you. Then you give us freshers, or like who are initially into your career, you can try to check and see like, okay, this is something that I like, so this is what I need to pursue. Or you can also decide, okay, this is not what I thought it was, so that initially in your career itself you can switch to another role and see like, okay, so is this I'm really up to my liking? Okay, so this is my like, this is what I like, this is where my passion lies, so that you can take from there. So that's what I'll be giving here. So it looks very simple, but honestly like it covers almost everything. So this is like what I would say. Okay, so it's not like what, like it's not like what is the design pattern, I was put something else, okay, it's a typo. So it's like this is the plan I want to give you, this is the roadmap. Instead, I don't know why I typed that. It's like this is the roadmap I want to type, but it came there. Okay, so the roadmap is initially, like I said, SQL is your entry for data. Without SQL, you cannot do anything. So start with basics of SQL. Understand like how you write a basic SQL query, retrieve data from some table, some simple databases. Try to come up, if you go for any of these basic tutorials, understand it, try the query, take some data out of it, come up with some, try to get a very specific. You look into the data, understand the data, then you yourself write some use cases for you. Then try to get the query and write the query and get the result out of it. The next I said, right, SQL is, it's for every role you need to know SQL. The next is like advanced DB concept, in the sense like role to role, it differs. In the sense like data analyst and data scientist doesn't need to look into this DB concept, advanced one, like I said. In the sense like how to store data efficiently, how does an index work, how does a particular database works, how does it different from a different kind of databases, how is NoSQL and SQL works internally, and how is a row versus columnar database and how they are working efficiently. or how is a data big like big data technology warehouse, how it is differs from normal databases. Those kind of very advanced technologies is mostly will be helpful for machine learning or data engineering, but you won't be needing if you are looking into a data analyst or data scientist. Then mathematics and statistics, obviously it's mandatory for data scientists, and it's kind of depending on the role and the organization. Data analysts might need or might not need, so it's kind of like a yes for data scientists and maybe for a data analyst, but also like a yes for a machine learning engineer. For data engineer it's kind of a maybe, so it's not like definitely needed, but it's good to have. And programming language, it's needed for almost everyone. Like I said, any programming language require like Python, R, Scala, Java. So these are the major programming language used across, and definitely you should be knowing any one of these languages. Maybe like certain level for data analysts and data scientists, some basic to some not basics, an intermediate level is okay. But for machine learning engineers or like data engineers, they should be like advanced. They should not be in an intermediate level. They should be in advanced level of this. And data visualization tools, data analysts and data scientists may need it, but machine learning engineer or data engineers don't need it. So visualization tools similar to what I did, Power Tableau, Power BI, and all those things. And next is big data technologies. So everyone might be need to big data technologies and I kind of group them together, big data and ML and machine learning, deep learning technologies. Let's say first for looking into big data, the level everyone might need to have a certain level of understanding, in the sense like data analysts and data scientists should know to a basic level how they can retrieve data out of it, how they can write some efficient queries out of it. That's the level they want. But for machine learning engineers and data engineers, they need to even know a one level further, how the data can be stored very efficiently, and how that they can enable others to easily retrieve this data. So those kind of things they have to know. And machine learning and DL is very focused for machine learning engineers and for data scientists. And the cloud technologies, like I said, like it's good to have like understand different cloud data technologies, understand what are the commonly available services across different ones, so they can look into it. For data scientists and data analysts, it's okay for them to have them, but for ML engineers and data engineers, it's a must. They should know, because like only very huge organization work or they have the capacity to have run their own data centers. But for normal sized or like even because some of the bigger organization, they decided okay, it doesn't make sense for us to have an entire department to run our data center, we will just go for public cloud like AWS, GCP, Azure, and then they just pay them and use the services there. So it's obviously better for everyone to know like what are the commonly used features, particularly focused on data and stuff. And like data scientists should know those, data scientists should know this, but data engineers and ML engineers should definitely know how to use them. Then next is like build your portfolio, in the sense like I would say like take some open source data sets or some open source technologies, try to build application on yours, like for you take a there if you google for commonly say like for a data engineering project, for data engineering project, machine learning project or something, that'll be commonly used use cases or a lot of stuff. You kind of like have to build some stuff, host it in GitHub, so that like if it's in GitHub, other people, if it's really good, other people use it. Or like and when you go for an interview, the interviewer will know, hey, actually you know this stuff, so that's how you used it, so that they can they will kind of like they already know that you have it. It's kind of how to put it, it's good to have, uh, or I would say in my perspective it's a must have, like have a proper GitHub profile, build all this so that the users can kind of use it, and like the interviewers can see it. It's kind of give you a competitive advantage. That's how I see it. Cool. So finally, I would say we are almost nearing to the end of this. So if you have any questions, I also like we'll have this Q&A session after this for the next 5 minutes. And if you have even more questions, you can see my website, my email. You can ping me there, email me. I can try to answer it as much as possible. And mostly I will try to answer everything as now and then here in the QA session itself. Yeah. And like I said, here is a reference. I said I use ChatGPT to proofread my presentation and everything I put. And yeah, these are like credits to like the different ones I end up used. So basically we can still here, I put it here. So let's go for Q&A sessions. Like if you have any questions, please put your questions in live chat so that I can answer them. So I see like here Abhishek has asked, is it like, can I be a data scientist while studying CSE? Which is better, BTech, data science, or CSE? So, okay. So if you are going to be like a data scientist, like I said, if you're already studying a very particular job in data science, like course in BTech data science, obviously you can go for data scientist. But just because you studied CSE doesn't mean you cannot be a data scientist, right? You study software engineering, like you study the basics of computer science and everything. Then you come here and then you can learn the skill set. Like I said, these are the things that you need to learn. You learn them and then you can go. But even if you take the BTech data science or CSE, both of the places you are deep diving into a lot of mathematics. In CSE, you have a lot of maths papers. So obviously you will be learning those and then you can implement them, or you can learn some courses on the side. So what I meant is like, just because you studied CSE, it doesn't means that you cannot be a data scientist. That's all. There is nothing stopping you. You just follow the roadmap I kind of showed you, and then you can be a data scientist. Yeah. Can a developer be a data engineer? Will the experience be useful? Navneet, like, developer means, what do you mean by a developer? That's what I need to know. So can you say like, what do you mean by a developer? Is it like, because even if you technically put, data engineer is also a developer because he develops application. So it's, let's say if you are a, let's say you are a front end engineer, front end developer, or a front end engineer, and kind of a mobile app developer, and then you want to move into transitioning into data engineering. Obviously you'll be, it will help in a sense, like, definitely it will have a competitive advantage in the sense you will be doing a lot of coding. So obviously in those kind of developer role, you already did coding in a different language. In the sense, you have to learn a different new programming language if you haven't worked with what is being used in data engineering, and learn a different framework from what you have used there. But it will definitely help you because you already know like the best. It's not going to change in the sense, like, let's, if you are a front end engineer, like you write JavaScript, if you write web application, okay, software engineering, like I said, like, data engineering is software engineering. So let's say you write some backend applications, it's going to be still front end, not front end. You will use the same knowledge and transpose that into your data engineering. In the sense, you are going to use the same set of software engineering best practices. It's not going to change at all, right? Because, like, let's say you use back end technology, or like a front end, even let's take very front end. You are using a full stack developer, you use a lot of JavaScript, and there whatever you are using, right, writing classes, inheritance, interfaces, simple like for loop, while loop, arrays, they are going to be same in every single language, right? So obviously it will help you. You can obviously transpose. The only thing is, like, you need to learn like what are the technologies that are frameworks that are used for data engineering. So data engineering depends, like, either you have to learn like Python, mostly Python or Scala, depending on like which company you are applying for. Let's see like what are they usually generally using, Python or Scala. Then learn those language, and what are the framework they use. Is it Apache Airflow, DBT, Spark? You just learn those languages. That's all. Yes. I hope it answers your question. So do anyone has any further questions? Please let me know. So we are also on almost 2 more minutes. If any questions, please type out your questions, or we can end the session anytime soon. Yeah, I hope that helps you, Navneet. Yeah, thank you. Yes, so we are on time. Is there any questions? Yeah, so there is Jitan asking which programming language is mostly used for data, used by data analysts. So data analysts, mostly it's Python and SQL. That's our go-to. And especially in Python, there is this package called pandas. So those are the major, like, widely used for data analysts. I don't know, like if basics of computer science. So let's say if you go for data, so how do you put it? If they obviously you need to know some basics of computer science. In the sense, like I'm not saying that they should know like writing programming language, writing code, but they should know at least some basics, like what is a DB and how someone can write a SQL query. So obviously, some basics of computer science is needed for everyone. That's how you put it, because you are going to use a computer and do something, so you need to know some basics of computer science. You have to build your basic computer science skills, understanding like what is a website, or like how is it communicating with the, how is the website built, front end, back end, how is the data stored, where is data stored, the very basic things you need to know. And then a person can focus on, okay, this is how the data comes into the database, and then they can focus on being a data analyst. Okay, I write some exploratory analysis query, get those data in. So but I would say it's not like you cannot expect saying that I don't know any computer science, so generally I can jump into it. I mean, you can learn, you can take some courses to study those, being a data analyst or a B analyst. But even in this, like there will be some basics of computer science and everything kind of involved inside it. But I would say computer science basics, like basics of computer science, is necessary. We cannot skip that part. Yep. So, any more questions? I can spare another minute or two, as we can end it here. Yes, so I don't see any further questions. Let's end this session. Thanks everyone for attending. If anything, please email and you can check with me. Thank you.